heap files are not efficient when we have range queries. So the first solution to this problem is using sorted files. In the sorted file, the access path will be a binary search. So you know that the order of the binary search is log n. So here we will, if we have f number of pages, we will have log 2 of f. So another advantage of sorted files is this: successor rows will be in the same page. Therefore, the number of the page faults will be minimized, and also the pages will be sorted together. So if we put all the pages in the same track, then the seek time will be minimized. So this then the first lesson is that sorted files is much more efficient than heap files, because first of all seek time is minimized, and also for range queries successive rows are the same place. Okay, for example, here you see two sorted files. So there is another problem here. The problem is when we want to insert some row to the sorted file. So, or we want to delete some row from the sorted file. So in case of insertion or deletion, we need to, at the average, we need to move or move the rest of the records, or shift the rest of the records upward or downward, because when you are inserting one row, then in order to keep the file sorted, then the rest of the keys should be replaced and find a new place for the rest of the keys. So there are two solutions for this problem. One is leaving some empty spaces in the pages. So in this case, we need to we cannot utilize the whole disk space we have, because for each page you will keep some empty space for further insertions. Also, the problem is not solved completely. Why? Because if the empty space is also filled, then we need to split pages. So this is called the empty space, or the non-empty space in the page is called fill factor, and we can and fill factor plays an important role in the efficiency of using the space of the disk. Another solution is using overflows. Okay, you know what overflow is, right? If a page is filled, then what you are doing is basically you keep the page already sorted, but if you cannot fit anything in the page, then you will use another page, and you will use a pointer to show that who is the next page, or where the overflow rows are located. So the main disadvantage of this is that you don't have the records are not sorted anymore, and therefore the cost of the searching is not exactly log of f, and also since they are not sorted anymore, then the two advantages we had here, minimizing the stick time and minimizing the time for the range queries, will not be achieved. And here is an example of this. The picture is a bit moved upward, but this block should be down, and you can see that here after that record there will be an overflow happening over here, and the rest of the records will be saved in another place. Here is the overflow page for the first one. You can see that this row should happen in that place, in the first page. So, okay, so we are done with the two traditional way of storing information. Now we are moving to indexes. So, what are indexes? Indexing is a mechanism to locate the information we are looking for as fast as possible. So it's a kind of mixture of an algorithm and data structure, right? We need to have an additional data structure to show and trace how you store the search key. So in the indexes that we are working based on search key, okay? Do not confuse. Search key is different from the primary key, okay? For example, in the student table we had in the registration system, the student ID was the primary key, okay? But the student table also could have another search key, which was the name of the student or last name of the student. If you are frequently searching the students based on the last name of the student, then it's good to have an index on the last name. And when you are looking for a specific person, then you can find the person as fast as possible.
What if the name is same?
The index will handle it. Don't worry about this. Okay, the search key is not necessarily unique. So it was a good point. The search key is not necessarily unique. And all of the search index mechanisms we have, like using hash map or using B+3 or B3s, all of them are able to handle duplicates.
But why can't we use search key primary key as a search key?
We can use it. Basically, we also usually primary key should be also indexed. Why? Because primary key is used to calculate and compute and answer joint queries, right? When you are joining to table, one key from the student is the primary key from the student is a foreign key in the course registration table. Then when you are computing this join, every time you are finding a record in the course registration, the database is supposed to go and look for this specific student ID. Then the search based on the student ID is very frequently happening. Okay? Then it's also good to have an index on the primary key. But you should remember that the candidate key or primary key is completely different from the search key what we are talking about from now on. So the index structure contains index entries and also location mechanism. As I told, the index entries can contain the data tuple by itself, or index and table are, in this case we are calling index and table are integrated together. Okay, or the index could be completely separated from the data entries, and in this case you will need a pointer to point to the data entries, right? So this pointer is completely different from the pointer you are using in programming languages, right? This pointer is some sort of pointing to some place in the file, so it's not the same as the structure that you use in the other pointers. So what is the location mechanism? The location mechanism is an algorithm you are using to find an entry and also the data structure for locating and indexing the entry. Suppose that you're all aware of, you are familiar with binary search trees. Are you? Okay, so good. So in the binary search tree, or in the binary search tree, what is the binary tree? The binary tree is the data structure we are using to locate the key. Okay. Binary search algorithm. What is it? When you are tracing on the data on the binary tree, you have an algorithm based on the key. You're comparing the key with the node. If the key is larger, going for example to the right, is smaller, going to the left, and this algorithm, this simple algorithm is also the algorithm you are using in the location mechanism. Okay, so index entries are can be stored according with the search key, or they can be completely independent. So, in some cases, for example, for hash3 and hash map and B3, the entries can be sorted, and entries and search key can be stored all together, okay? But we can also have cases that the search key is stored on a different place. Okay, so index structure. This is the simplest. Suppose that you have a binary tree, okay? In the binary is an index structure, okay? Are there keys are sorted? They are
The binary.
in the binary tree.
What do you mean by sorted?
Can you find a range of the keys, right? Do the data structure give you a sort mechanism?
Yes.
How, if you traverse the tree in order traversing, okay, then the tree will be sorted, right? In order mechanism, you are going to the left, visiting the left side, going to the parent, visiting the parent side, and coming down. This is a sort mechanism. Okay. Suppose that you create the binary tree first, and then you want to sort the information, or you have a range query. Okay. So what you are doing is you are finding the first bound of the first element, the start element of the range, using the binary search algorithm. Then you can have this in order traversing of the tree to find a sort of those records. And the following records we are looking and you are visiting is the records that you have sorted. Okay. So here, if the information, if we are using an index that is giving us directly sorted value of the entries, then we will have this advantage that in range query we can find the values as fast as possible. So this is the set index mechanism. In the index mechanism, you have a search key. You give the search key to the location mechanism. Location mechanism is looking for the index entry matching the search key. Okay? When it finds the index entry that matches the search key, then the index entry is pointing to the actual tuple, and then the tuple will be retrieved easily. So the storage structure, of the file containing a table can be heap file, sorted file will be studied, and also integrated file containing index and rows. Okay, these are this is also a type of the storage structure. So in this case, entries contain rows. Index entries contains the rows of the information. Okay. For example, in B+3 and hash map, you have the hash map, and in the hash map, when you locate the key, then you can directly access the value, and everything is stored in the same place. So this is an example of integrated the storage structure. In the integrated storage structure, you need some part of the data file is required to keep the index, or generally the mechanism for locating index entries. Okay, data structure and somehow sometimes the also algorithm together, and the rest will be the index entries or rows. Okay, index file could be stored in the separated file structures, okay, in a separated file. In this case, you will have another file, and in the file you will have index entries, and index entries are pointing to the main file containing the data rows. Okay, you have the location mechanism over here and the index entries, and then the index will be located. Okay. Okay, so the main disadvantage of indexes. What is the main disadvantage of indexes? First of all, keeping an index is not an easy way, or isn't easy thing. Why? You need to handle another additional data structure for future comfort. Okay, so additional index. First of all, you have to create the index mechanism, which is usually costly. Also, the it adds additional I/O to update the indexes, because when you are deleting something from the, for example, binary tree, then you have to update the binary tree, and sometimes it is very difficult. For example, in case of binary tree, you have to move some part of the tree based on some strategies, right? And the indexes must be updated. SQL92 did not have instructions for adding or removing indexes, but later on you have indexes in the later SQL versions. So now let's talk about the clustered indexes. Okay. Suppose that clustered indexes are those indexes that are storing the data and also the index all in the same way. Okay. For example, if you index the student table, okay, based on the student name, and also and then the index created for the student table for the last name will be clustered index for what? For table of students. And usually integrated data storage, the one that we saw here, where you have this mechanism for locating and then the index entries together with data. This is always clustered, because the index these are sorted based on the index entries, right? The search key index. So basically, particular index cases, like we will see about the tree and B plus tree and hash map. Also, they are also always dictating how the data should be placed in the file. For example, how hash map works, you have the index key, okay? You give the index key to the hash map, it returns you a value, okay? And the value is the place that you have to either put the data entry, okay? And if it is, when you are giving a value to the hash map, the hash map is basically sorting the information based on the index, based on the search key, right? And then consequently, the file will be sorted based on the search key. So basically, usually, create table is creating an integrated clustered index based on primary key. Why? We explained now, a few minutes before. Why? Why in the student table we have index on student ID? Because it is required when you are computing all the joins, right?
Yeah.
Suppose that you have the join between course registration and the student, okay? When you compute the join, you have to match all of these student numbers equal, okay? This matching requires a search on the student ID. So it is very usual, it is very common that the search based on the search primary key happens. So by default, create table creates indexes based on the primary key. snapshots on my slides, but I will put it later. Snapshots. Okay, so let's work on some practical examples. I'm sure that everyone worked with Microsoft SQL Server. So Microsoft SQL Server is a very famous DBMS that we are supposed to learn in the class, and we will have some questions in the midterm about Microsoft SQL Server. So in the Microsoft, I'm not talking about how you should install the Microsoft SQL Server. So installation of these softwares are not part of the topic of this course. So I assume that you know how to install it. But when you are installing Microsoft SQL Server, first of all, the lightweight Microsoft SQL Server version is available on the with the name of Microsoft SQL Server Express. With a free license, we can install it, and this is the only part of the DBMS we are using in this class. Don't worry about it, and nobody requires to purchase for the Microsoft SQL Server. Basically, you cannot also afford it if you are not very rich. So Microsoft SQL Server, when you are installing Microsoft SQL Server, you need to install two separate packages. One is for the storage engine, and the other one is Management Studio. Management Studio is a place that the user or database administrator or database engineer can connect to the underlying storage engine, and the storage engine is the part that keeping the physical schema, right? So the storage engine is not necessarily located on your computer. It can be somewhere on the network, and the Management Studio can find any other servers on the network. Similar to Oracle, you install Oracle client, and the Oracle client either can use the Oracle server on your computer, or it can be connected to the school's Oracle servers, right? So this is similar to what we have, but much simpler. Okay. So I've installed Management Studio 2016. If you use 2014, if you do the same thing, I'm not adding anything. We are not using any advanced structures. So when I enter the this Management Studio, you will face this dialog which asks which server you want to connect. And you connect the server. I connect the server that I have installed on my laptop. And when you are installing the database storage engine, then it will ask you if the security needs to be either based on the Windows security or mixed. Mixed means that it is using another username and password for each of the users of the database stored in the database management system. So I used to, since I don't have any critical information in this database, and security is not required, except you may have find the questions or the tables related to your questions. So I don't have any specific requirements of securities. Therefore, I'm using just Windows authentication. Just let me connect to my server. Okay, so when you are entering the server, you will see that the storage engine on my laptop over here, and there are a few options over here. Okay, simply I create a new database with this command, new database. Okay, first of all, Please ask you. It will ask you the name of the database that you put registrar because listen, you may there are sample databases online. Okay, AdventureWorks, Northwind, or some other databases. Okay, Northwind is the oldest one. AdventureWorks is the latest one. Okay, in the exam, like employees database, go over it and just see what the tables are. You know, it will look good for your exam because the queries will be from those databases. Right? I'm not gonna create a new database for you. So I create a database with the name of registrar, and for the owner, I'm doing okay. I want to add some owners to this database. So for the logins, I add. This is my user and my laptop, and also this is the administrator or root. People are coming musically. People are. But in the background, it's very funny that funny is coming with music. So okay, you add this. I add this set of users and then okay. So you see, two files are created. One is log file, which is we will talk about log file. The music section of the class. Make your cell phone silent. So there will be two parts of the. There will be two files for this database. One is log file, and the other one is rows. Rows is the part that you are keeping what? You are keeping data entries and indexes. Okay. So if the rows are the indexes, so this database will be integrated index, right? The type is integrated because the data index is already in the file. Okay. So and also we'll talk about what's data. Okay. There is one option over here. You see auto growth and maximum limit. First of all, you can put the maximum limit on the. This is for physical schema manager. You can put the maximum limit for the data file. If you put the maximum limit, then you cannot add anything after maximum limit is reached. But what is the auto growth? Auto growth.
It increases.
It increases the size of the page.
According to the.
And this should be a multiplication of the page size, right? You cannot have 2 bytes or 3 bytes. The auto growth is multiplication of the page size. There are other options over here. I will put a file on Canvas about all of these options, okay? And some of them you should be aware of and should be familiar. For example, this is here, for example, there is a part in the options, it's called automatic, which is, for example, in the auto close, it closes the database, current database, if no connection is already using the database. Okay, it means that all the files are closed and the file pointer in the operating system will be released. Okay, if the auto close is true, then it will be closed automatically. Otherwise, then if someone is establishing a connection to the database, then dropping this connection, this database will remain open, which means that the data may be, and it will have an overhead on the operating system and DBMS also. other kinds of information here, you'll read it in the file I put. For example, the statistics are required to make the query execution optimized, okay? We will see why we need the statistics later in the course, but here, for example, in the auto options, you tell to the DBMS, sir, based on your requirement, add whatever statistics you want to the table, to the database. Other sharing, auto sharing, or other things are explained in the file. And the other things are about the how null value and how other ANSI and encoding values will be kept in the system, the language, and all of these general information. Some of them cannot be changed. Okay. For the recovery, there is an option checksum. What is the checksum?
Data verification, where is the current one?
Where is the data verification? We learned about checksum last class, right? There was that bit that was set based on the parity, right? This is the checksum. They keep the checksum, and the recovery. We can change the recovery mode based on checksum, none, or turn page detection, which means that just detect the page which is damaged, and that's it. Definitely, having the checksum is the most difficult one for this guy, because it has to follow why. Why checksum is very difficult for this guy?
It takes more time to,
It needs to update those parity bits, right?
every time the data changes.
And every time the data changes, that parity bit it should be updated. Therefore, this is much difficult, but for critical databases, you have to have this option set up. And also other stuff, or encryption and other things that relate to security. Then create a database. Okay. Yes, let me. Create one table. Panindra. Tell me the name of the table. Panindra. The music. So we'll create a table for the students. Student ID, J. The student ID should be.
Numeric.
Why numeric? You select numeric.
Numbers.
Numbers or like
ID should be digits.
There is a reason you should like new. This should be the key, right? First of all, you know that the student ID should be the key.
So that we can identify.
What?
It should be the primary key for
It should be primary key. Why? Because this is a key, unique, and it will be used for joins. Okay. So, but this is not the reason why you are choosing it as a number. If this is a primary key, I told a few minutes ago,
join.
it is used for computation of joins. Then it will be used in search mechanism. What are you doing in search mechanism?
You're using it as
Comparing, right? Which one is faster, comparing strings or integers?
integers.
Integers. So then, as
I mean, it
Krishna
need
told
not to
you,
be.
what?
It need not to be recursive because.
It not to be, but it is not necessary.
Yeah.
But we do it for fun, make it more efficient. Okay, so I'll make it key later. Then Finder is as a first name, which is character. I'll put the character. Let's say you can change the size of the columns later, but many times if you change the size of the column, it will have a lot of time. It needs a lot of time to restore all of the
We
information.
cannot allow nulls in student ID.
No, I will change it later. Okay.
Yeah, primary key should not be.
And last name. So lastly,
The question is minor key.
let's say 40.
Yeah, that.
Let's put date and
Professor, we put where car, right?
for birthday,
No, no.
Yeah,
First name.
for what?
First
Last
name.
name.
First name. and
Why
last name.
put varchar?
Try to use it. SQL Server.
Varchar means that the size of
It's variable.
variable. So it is much. Then the data should track the size of the.
So actually what happened, varchar means it's variable, but we'll give the maximum size, if it is 50. So if we give for 10 letters, it will store the data of 10 letters only.
And you are wasting some space. Who is 250? Whose name is 250 characters?
I'm saying 50.
Okay, but it's not 50, it's much
No,
more.
that's variable. This is varchar, if you give maximum limit 50, if your
Okay.
name is having only 10 characters, it will store only 10. It will not take the other digits.
Yeah, okay, so this means that it's really variable size.
Try to add those
Okay.
stuff.
So if this variable size, it means that the length of the record will be variable. Okay, then the storage will be more difficult for the database. In order to make it more efficient, avoid using varchar makes the job of the development easier, but it makes it drops the efficiency when it computes joins and all of those extracting information. Why? Because if the length of the record is constant, it can easily track and it can locate pages much faster. Okay, so that's enough. Just set primary key and then all will be removed. And let's save it. Okay, so I saved it, but in order to see this as a saved item, I should do what? This guy should be refresh because we saved and the structure was saved on the structure was saved on the database engine, the local engine you have, but it's not shown immediately in the object explorer you have here. So it's, you need to refresh it. Okay, so let's add one more table. First ID. Again, I will put one first. Okay, I don't want to put course ID with integer or integer. Why? Because
It could have
it could have characters in it.
characters.
Yeah. First name. Textbook. Okay, and then I make first ID. I make so then I make name. And then I refresh this. And so, okay, so here when you open the tree under the name of the table, you will see different parts. For example, columns. If you open the columns, you will see the columns of the table. And with the keys, you will see the key on the table. You can add constraints and also triggers. You can add triggers over here. Okay, did I set the nested triggers on here? Optional takeaways. Okay, nested triggers is the optional table, right? Let's save it. Okay, there was an option for nested triggers. I don't find it, but it's very interesting that if you don't turn on that option, then your trigger should be just one level. Okay, so now we have, go to the indexes. We talked about indexes, right? So in the indexes, you can see one index. What is that index? Yeah, gentlemen, sorry, just. Okay, so why?
Because it is easier to.
Right, it's easier for the computational joins and all the computations. What is the? Okay, this guy is. We talked about this, right? A few minutes in these slides. This guy is a cluster, right? Because you need to the sort is also kept with the index
Yes.
index entries, right? Okay, now. Fine. Let me index the table based on what you order. Tell me which book you want to do an index. I want to add an index. First of all, just pay attention when you have several indexes, you can you have different options here. You can rebuild an index, which means that maybe you inserted or deleted something, and you know that the index was not updated, or the updating of the index could be lazy.
We have to do that manually.
Right?
We have to do that manually.
Sometimes, yes. Or you know that if you know that the index is damaged by other processes. So rebuild is doing the same thing. Okay, so I want to add another cluster index. Can I do that? So, is there any bet?
Yes.
Say yes. Okay. Anyone? No?
Can you repeat the question?
Well, just you talk to the.
I said
Think about how is it possible. Okay. Can the index could be clustered again? Can I add a cluster index?
I mean,
Say yes. Okay. So
because you were storing in the same file, so you can add another one. That'll be-
cluster. What was the meaning of cluster?
You said for the cluster, it is in the same file, right?
No, it was integrated. The integrated
So the
index.
cluster is different.
The cluster is the one that's storing the entries based on the key, right? It was we talked
Yeah,
about
so-
B plus 3, and also B plus 3 was an exact.
So we can have another one if it is from
Okay, so one cannot, one can. Okay. So let me do this. Okay, so Faringa, choose one. Last time is okay? Yes. We go. Okay. It was added. So you were right. Right? So we could. But let me do okay? No. Why? There is an error.
because they have one, right?
There's one person in this class just listening to the course. I explained that you cannot have more than one cluster index. Why? Because if you sort their entries based on the primary key, how can you sort it again based on the last name? Just one person is just listening to the course. Okay, so I can let's add a non-clustered index. The rest of the indexes are for XML queries. We may not get to the point that we are backlogged of the schedule, so we cannot maybe cover XML files and XML queries. So, but you know, now we want to add one non-clustered. Let's see, last name. Can I do that?
Yes.
Yes. Yeah, we added another index cluster. Okay, there is a revealed over here also. You can reveal the index also. What is the reorganization of the index?
After we delete or
Okay.
update something,
Okay. After reorganize it.
we
based-
indicate.
Right. Reorganize it based on the updates we are doing based on. So it's kind of similar to fragmentation. You're making it. For example, we will see what B plus series. In the B plus series, we have a fill factor. What was the fill factor? A few minutes ago, we talked about fill factor. What was the fill factor? Empty spaces in the sorted files.
What did you say?
Fill factor. What was the fill factor? Empty spaces we kept in the sorted files. There was we reserved some place for
Yeah.
adding.
So you said that if we have a reserved place and we need to enter more stuff, we can.
We can, and then in this case, we need to have to specify a fill factor, which is initially making the reserving some space. Okay. So again, in the several data structures or indexes, you need to have a fill factor. For example, B plus 3 is a tree with a node growing or shrinking. Okay. That growing or removing shrinking node has some arrays as a storage because it wants to make it faster. That array has a fill factor. Okay, reorganization means that it's not revealed. Reorganization is if the tree is, if we had a lot of updates and the fill factor is not equal and it's not organized. For example, you have a node with a lot of records. You have a node with 2 records. This is not organized, then fill factor. Reorganization means that just make everything from the beginning, organize that with a structure. So making everything correct today.
And in this case, how can we find out if it's organized or not?
If it is not organized or after a lot of updates, definitely it will not be organized. Many times, if you are doing some search or some queries or some join based on the search key, and you see that the performance is dropped, one option is going here and reorganize it. And if you are sure that you have a lot of this. Usually for example, for the student table, because you are not adding or removing a lot of the students, it's not, you don't need reorganization a lot of time, okay? But for example, if you are doing a transaction processing, then since you are adding a lot of withdrawal and addition of the money to some accounts, then it needs to organization several times.
Professor, why can't we use all the space in the index?
We will talk about the indexes because the structure of the B plus is in a way that at least 50 or 40% of the index will be kept empty at the beginning. So when you are adding, that 40% will be, when you are adding a record, the record may fall into this space in the index, this node, okay? If it is completely full, then you have to break it down to 2 different nodes. And this breakdown, similar to what you are doing, for example, in the B tree. In the B tree, if you delete, you need always reorganize everything, okay, in binary trees, okay? But in the B plus tree, if you add something and if insert happens to the same node that it's filled, you have to rebuild or break the node. And this break may go up, and you need a lot of changes in the index. It takes time. Therefore, they keep usually some part of it empty. And that part of the empty, this empty space here in the index is different from the empty space you keep in the sorted files. Why? It's good to have fill factor over here. Why? It was bad to have fill factor in the sorted files. Why? Extra memory was taking, or wasting time in the sorted file. Wasting space. But here, this space is very small. You have this search key. It's not a search key and a pointer. So having a fill factor, a small fill factor is not damaging. You're wasting a lot of memories. Okay. So we'll talk about organizations and columns later. Okay. One point one point in order to, so similar to what they had in the MySQL, you'll have some exercises in SQL Server as well. Okay, and so you're expected to know SQL Server in your midterm exam. So my suggestion is go and download at least Northwind and AdventureWorks examples. Northwind is very easy. How many people have worked with Northwind? Played with Northwind database? With Northwind database, sample database?
So can you spell that?
Northwind.
Oh, not Windows. Product database.
Yeah.
Northwind.
This is the spelling. I was pronouncing properly. Northwind, right? What? You work with that. AdventureWorks is similar.
It's in
It's
Access
not-
also, sir.
What?
I miss Access also. It's in
Yeah, was Access?
Access also uses one.
I haven't seen it in the Access, but I saw in the MySQL, the older version of the SQL Server, they had this Northwind as a tutorial thing. So you can use it as warm up for the next classes. In order to Northwind has a script, right?
Yeah.
Yes. As a script.
But we didn't have any data for Northwind.
No, I guess you don't have that data over Northwind?
No.
Okay, so so work on the AdventureWorks because you have data on the AdventureWorks, and in order to load AdventureWorks data, you have to. There is a wait. Okay, so in order to add the database, the AdventureWorks, because you have back files, you have bank files, then unique data also. So you use this wizard, which is SQL Server import and export wizard to import the data. Okay. So here you can use. I mean, all of these tools are with the Express. Don't worry about this. Nobody wants you to pay anything. Okay, clustered secondary index. Suppose that you have a you need to have a secondary index, and this index is clustered. It means that the records are the entries of the index is sorted as same as the entries of data file sorted, right? It's clustered, right? And it is not integrated. Why? The index I'm showing here is not integrated index. Hold on. The indexes are created. The indexes we created and in the database I created over SQL Server. Was it integrated or not integrated?
It was not
Integrated.
You
It's
said-
integrated.
Integrated.
Why integrated?
Based on that, the sorting is happening, so it's automatically integrated.
No, the integration is not based on sorting. Integration, we talked about integration. Integration is.
Because it wasn't present in the same.
You remember the files I created when I was creating the database? How many files I chose? 2. One was log, one was data. I didn't add anything. But if it is not integrated, you need to add one specific file for the index.
So it
Okay?
wasn't integrated.
It was integrated.
What do you mean by integrated?
Right? We talked about integrated here, right? Here, integrated was the indexes, the file content, the same file containing the rows and the index.
Yeah.
You answered the one question.
Yeah, I know, but then
So I didn't add any file. You remember when I was creating the database, how many files I chose?
2.
2. One is log. We told that log is out of our business for now.
Yeah.
The other one is data. So if it is not integrated, you have to add another file. You cannot keep the index on your memory. You cannot keep the index on your magic. Let's say second index. So data secondary index cluster. The data records are raw and sorted based on index entries. Also, the index is located in somewhere else. Okay, suppose that I am keeping a binary tree as an index. Okay, and binary tree is kept in the another file. Okay. And the binary key is based on the last name. Okay. And the file is stored based on the last name, not the primary key. Okay. So is it clustered secondary index?
With lastly.
No.
It has to be unique.
No, the cluster does not require.
Yeah, that was integrated.
No, it's not. First of all, it's not integrated. I'm keeping it in another file. It will work, but is it clustered or not clustered?
It's not clustered.
I'm telling you that the file is sorted based on the last name.
Yeah, so last
And
name
we talked
is
about with binary trees. Binary trees are giving you
sorted.
sorted, right? Because the in order traversing, right? So, okay, so it is clustered. It was sorted based on the last name, and the binary tree is keeping the last name. Okay, so it's sorted and it's clustered. So unclustered secondary indexes. What are the unclustered and secondary indexes? It's so simple.
So what do you mean by clustered secondary?
Secondary is that it's out of the main file, okay, and it's not primary key. Right? So unclustered means that it's not sorted based on the search key. So indexing trees are and rows are not ordered in the same way. Secondary index might be clustered and non-clustered with respect to the storage structure we are referencing it. So, this is an example of unclustered secondary index. So basically, primary index is the one, or main index is the one we are using, and we thought that primary index is usually, main index is usually primary key.
Yeah.
Okay, secondary index is the one that is on primary key. Okay, it can be clustered or unclustered. Okay, and if it, and usually secondary indexes are non-clustered. Why? Because we are usually sorting the information based on primary key, and the only clustered index we have is primary key.
What is the difference between secondary clustered and secondary non-clustered?
If we have a secondary cluster, we already sorted the information, or we have some additional table sorted based on the secondary cluster index. Okay. For example, you have a table for the students. You have another table for the students. The new table is sorted based on the last name, and you have a secondary index of the last name. Okay, and then this secondary index is cluster. You are replicating data to have something, or suppose that you are not sorting the information based on the primary key. You have another key, another index, which is last name, which is secondary index, but the data is sorted based on the secondary index. Okay, but based on the last name. Therefore, the secondary index is also clustered. But usually, secondary indexes are not clustered because clustered indexes are usually primary keys.
Yeah, primary. But we can still have one secondary index, right?
No, we cannot have one secondary index. If you are using
Because
this, if you are using main index is the main index is usually primary key, okay?
Yeah.
And you keep it integrated with this data file. Okay? Secondary indexes, those indexes that are not main index, they're not primary. Okay? It's not primary key. So if you sort the data based on the primary key, then you cannot have another sort on the same on another field. Therefore, whatever index you are adding will be non-clustered. Non-clustered. You saw that I couldn't add any clustered index over there in the table. So the command create index in the SQL 99 is creating an index, and basically by default is unsorted and secondary index. So this is unclustered secondary index. You see that the rows are not sorted. My question is now, suppose that what was the just remind me question. What was the advantage of clustered indexes?
It is sorted.
It's sorted for what? It was good for range queries.
Yeah.
So we told about range queries. For example, in the binary tree, what you are doing is basically first you go to find the starting point of the range query, the answers, and then traverse in order to find the rest of the records. So if it is sorted, it's good. If it is not sorted, but unfortunately for the secondary indexes, we usually cannot have cluster. Okay, so it's not, then we are not getting anything, any advantage on the range queries, but we still get advantages on single queries. Okay, the query is returning one single row. Okay, probably it's not secondary index on the last name is not good for searching the range of the names between Waseda and what was your last name?
Atmikul.
What's your last name? Will check, sir? Will check. So if you have this range, if you define this range, it's not good. Why?
Because there could be several same.
Because I don't have any cluster. So it's not helping. This index is not helping. But if you are looking just for the record of the Inkata, then you can easily find it. So again, cluster indexes are good for range queries. Okay, and also cluster indexes are minimizing the page transfers. Okay. Okay, so we'll continue next on Thursday, right? We will continue on Thursday.